let's look at this problem. Let PQRS be a rectangle of size 9 by 3. It is folded along QS such that the plane PQS is perpendicular to the plane QRS and the point R moves to T. Find distance between the points P and T and angle between QP and QT. Okay, let's say first we'll see what is given. So this is given. So PQRS is a rectangle. Now QS is a diagonal to that. So we are folding along QS so that R will become T. So we are folding such that this plane and the plane QRS are perpendicular. So instead of R we are saying it is T. So QTS is perpendicular. So if I see the modified figure, so now we are projecting it up. So P, Q, this is, now this is T. So these two planes are perpendicular to each other. So in order to solve this, okay, we are saying the size of this rectangle is 9 by 3. So we'll solve with the help of the coordinates. So we'll consider P as 0, 0, 0, Q as 9, 0, 0, S as 0, 3, 0, R will be 9, 3, 0. So now we don't know the coordinates of T, so we'll call them as alpha, beta, gamma. We'll call them as alpha, beta, gamma. So what we can do is, see here what we'll do is we'll find, so we are seeing this in completely in XY plane, right? So if I am lifting this face like this, so it means I'm only increasing the height. So if I'm increasing only the height, so if I know the coordinates about which it is being lifted, so what we do is I can only add the height. So what we do is we'll find the perpendicular onto this line. What is this? This is foot of the perpendicular onto this line. So whatever height is there, so if I extend this also, the height will remain the same. The height will not change. So the height will remain constant. So this point and this point both are one and the same. So about this point only I can increase the height. So how to find this point? So if I want to find this point, so this point is foot of the perpendicular from this point, right? So foot of the perpendicular from this point we can calculate. So this line equation QS we can calculate. So equation of QS is x by 9 plus y by 3 is equal to 1. So it is x plus 3y is equal to 9. And now we want foot of the perpendicular from R. So foot of the perpendicular from R to QS is h minus 9 by 1 is equal to k minus 3 by 3 is equal to, so r minus 0 by 0 is equal to minus of 9 plus 9 minus 9 by 1 plus 3 square plus 0 square, because z is not there, so 0 into z. So h minus 9 by 1 is equal to k minus 3 by 3 is equal to r by 0 is equal to, this is minus 9 by 10. So h is equal to 9 minus 9 by 10, which is 9 into 1 minus 1 by 10. So 9 into 9 by 10, which is 81 by 10. So again k is equal to 3 minus 27 by 10. So 3 into 1 minus 9 by 10. So 3 into 1 by 10, which is 3 by 10. So R will be 0. So we got coordinates of that point. So we'll call this point as M. So M is 81 by 10, 3 by 10, 0. So MR distance will remain fixed. So MR is equal to root of 9 minus 81 by 10 whole square, 3 minus 3 by 10 whole square, plus 0 minus 0 whole square. So this is 9 by 10 whole square plus 27 by 10 whole square. So 9 by 10 we can take out, plus 1 plus 9, so which is 9 by root 10. So the coordinates of T are coordinates 81 by 10, 3 by 10 and 9 by root 10. So P is 0, 0, 0. So PT is equal to distance between them. So it is 81 by 10 whole square, 3 by 10 whole square, plus 9 by root 10 whole square. So this will be 81 square plus 3 square plus 9 square into 10 by 100. So that is distance between P and T, and angle between QP and QT we want. So Q is 900, P is 000. So QP bar is equal to OP bar minus OQ bar. So now is minus 9I. So if I consider IJK, so Q is again 900, T is 81 by 10, 3 by 10, 9 by root 10. So QT bar is equal to OT bar minus OQ bar. So which is 81 by 10I plus 3 by 10J plus 9 by root 10K minus 9I. So which is minus 9 by 10I plus 3 by 10J plus 9 by root 10 K cap. So cos theta is equal to QT cap dot QP cap by minus root of QT minus root of QP. So QT dot QP will be, so if I do dot product, so there is nothing but minus 9 by 10, 3 by 10, 9 by root 10 dot minus 9, 0, 0. So QT is nothing but QR, because the length will not change even if you fold the paper. So QT and QR are both on one and the same. So QR is 3. So QP is 9. So this is minus 9 by 10 into 9 minus 9. So 81 by 10 by 27. So this is equal to, so if I see this 27 3s is 81, so 3 by 10. So theta is equal to cos inverse 3 by 10. So angle between QP and QT is cos inverse 3 by 10, and coordinates of T we can calculate using the foot of the perpendicular from R to the line QS.